Glad to see that you're all still here, and once again, I'm extremely grateful for all the positive feedback that I have been getting in this project, in this tutorial series. I've loved making them, and it seems like you guys are loving them too, so once again, thank you so much. So far, we have our character here with smooth movement, we got some coyote time, variable jump height, variable gravity, and input buffering. Alrighty, welcome back, everybody. Last episode, we added wall jumping, and you can already see that there's a new mechanic that we're going to add in this video. So we have our wall slide right here, and then we have our wall climb, and we can climb up, we can climb down. There is a stamina, so I just fell, and then, I made it so that we can't fall off the edge down like that. Same thing if we're climbing up. We can't climb up higher than that, but we can still climb down. So that's what we're doing in this video. Not too hard to implement, but a very important feature. If you've seen multiple of these videos, or even if this is your first video, if you've enjoyed this content, go ahead and hit that subscribe button. We're trying to hit 500 subscribers by the end of the year. I think it's totally doable, but we can't do it without your help. It doesn't cost you anything, and if you end up changing your mind later, totally fine. But let's try and hit 500 subs before the end of this year. So as with most things in this game and in this project, we have some new animations. So our player is right here. If we go down, we can see our character base. So I am going to drag in our new character base. Alrighty, perfect. Character base has been added in. As you can see, our image gets completely changed, and so we need to go to our sprite, and we need to go vertical frames up 1 to 11. Yep, 11 is where we're at now. Perfect. So all those animations should work just fine. And we're going to add in 3 animations. So the first one is going to be wall grab. And if we cycle through our frames, our wall jumps and kicks. There we go. So that's our wall grab right there. Perfect. So there is our wall grab. We're going to keyframe this one, create, keyframe that next one, zoom in. I added in the wrong ones, so let's delete those, reset that, go back to our sprite. There we go, keyframe 1, keyframe 2, perfect. And we're going to set this to 0.01 second snap. Want that to hover right on 0.3. We'll make this whole animation 0.6 seconds. Now let's play it. Want to be looping. That might even be a little fast, actually. Let's move that to 0.4. Change this to 0.8 seconds. There we go. I like that better. Perfect. Next one is wall climb. So let's go back into our sprite. Cycle through these empty frames. Okay, so there's 1. Yep, create that. 2, 3, 4. There should be 4 frames total. We'll zoom in. That's a little too much. 0.2, 0.4, 0.6. Once again, we'll make this 0.8 seconds. Let's see how it looks looping. That should be good. We might need to slow that down later, but that should be good for now. And then the next animation is our wall slide. Now, obviously, a lot of these animations, and especially the wall slide, they're static images. But the sprite sheet is set up so, like, if you're a better artist than I am, which I guarantee you are, you can just add in your own animations and it'll work just fine. And our wall slide. Perfect. All of those are in. So the next thing that we are going to need to do is we're going to need to implement several ray casts. So we've got these two ray casts down here, and these are for our wall kick. And we've put those down by the feet because we want to be able to kick when the feet are contacting. However, for a wall climb, and you can change this and do it slightly differently if you so desire. So these two ray casts are for our wall kick. We're going to add a couple more for climbing, and you can change these as you want. I usually do one like right here and then one up here. And what that allows me to do is I like the player to only be able to climb if their feet and their hands are technically on the wall. You can have different features though, like you can make the climb only depend on whether or not their hands are there. So that way, they can kind of be hanging off like the ledge on the bottom of a wall. You can totally do that. And the only reason the way you would change that in code is just by changing which ray casts you're checking for your collision. So I'll be checking like 2 up and bottom, whereas you will just check, upper ray cast. So in our ray cast, we have these here, and I'm going to rename these wall kick. That's going to be wall kick left, wall kick right. And if we rename them there, we're going to have to do that here. So wall kick left. This will be wall kick right. We change these to left. And that's going to throw errors down here. And the reason we are changing these is just to make them much more descriptive. Because we're going to have so many ray casts by the end of the series to determine different things that it'll just be best if we have them very descriptive. Okay, next up, we're going to add another node 2D. And I'm going to call these wall climb. And remember, the node 2D is literally like, it's just, we're using it as a folder. It doesn't have any functionality. It's just, we have to use a node 2D because node 2Ds over here on the right have a transform property, which means that they will then follow our player. If I were to switch this to a node in the level, our raid casts would just stay like right here. Even if the player is like down over here, the raid cast would stay there. But because they're node 2D, they can follow the player. So that's why we have to use a node 2D. All right, so this next one is going to be wall climb top left. And then we're going to have a wall climb top right. And so we're going to use the wall kick and the wall climb as our checks to determine whether or not we can actually kick and what. We're going to use our wall kick and our wall climb. I'm going to check these two to make sure our player can actually climb. If you want it to be just based on like the hand positions up top, then you can totally if you want to make it so your player climbs when just these upper ray casts are contacting, then you can totally do that, and you'll just change your function later. Okay, and I have these set like this. So I'm going to move this to negative 4.01 and then switch this to negative 3 because that's how this guy is set up. And we'll do the same thing here. This will be 3, that'll be 0, that'll be 0. Our transform is going to be at 3.01 and no 4.01. There we go. Okay, so now we're going to add 4 more ray casts. I know, sounds ridiculous, but it'll make the game quite easy. So this is wall climb top bound left. So wall climb bounds top left. Actually, let's change this to limit because that's a shorter word. Wall climb limit top left. Perfect. And wall climb limit top left, the only difference is this is going to be -1. And we're going to copy this node, paste it, and this will be wall climb limits top right. Right 2. Sick. Wall climb limits top right. This one will switch to positive 4.01 and -1, targeting positive 3. So literally the limits are just sitting a pixel above those. And once again, if you want the player to be able to climb higher, just drag this up higher. I just have mine set like that just because that's how I set it up. But this system is flexible to the point where you can wall climb limit top right. There we go. That's the name we want. And then copy those, paste them. So limit top right, wall climb limit. Nope, that's, oh boy, wall climb limit top right. There we go. This one we need to be bottom left, and there's probably 2. Yep. And we'll just switch this one's Y to be the wall kick left, which is at 12. This will now send down to be 13. And then this one, bottom right. And then same thing. We'll send this to be 13. Perfect. Alrighty. Those are all the ray casts we'll need. And so as a reminder, these like inner bottom ones are for wall kicks. And then these upper ones are for wall climb. In my function, I use both of these to see if the player can climb. But you can easily just exclude the wall kick ones and just use those two, because that'll still allow the player to grab like the bottom corners. And to change it, you can just change this climb bound to be 1 pixel below this to make sure the player, doesn't move beyond. And actually, I might even change it in this video to show what that's like, because actually, now that I think about it, that would be cool. So we might do that on the fly. Okay, now that we have that, we need to get all of these nodes. So on ready, on a new line, please. On ready variable ray kick, ray cast, wall, climb, top right equals raycasts wall climb top right. On ready variable raycast wall climb top left. Perfect. And now we just have 4 more to go. On ready there. Actually, here we'll make this easier on ourselves. We're going to drag new line, drag new line, drag new line, drag new line. And then we're going to copy this. This is what you call very lazy programming. But when you're making a YouTube video, you need to be faster. So I'm going to go RC. Look at that. Paste that. Paste that. Paste that. Alrighty. Those are long variable names and they just keep getting longer, but I'm a fan of descriptive variable names. That way you're never confused. Perfect. Now that we have that, we need to implement 2 functions. So let's minimize a lot of this because we don't need it. So first, let's implement our wall slide. So we're going to add function handle wall slide. And what we're going to say is if, we're going to open up 3 parentheses, wall direction is equal to vector2 dot left and key left. So the wall's to our left and we're hitting left, and raycast, and this is going to be climb top left dot is colliding, and raycast wall kick left dot is colliding. So that's way out there. And we need 2 of those to ends. So then if you hit enter, then tab in, you can keep going on that line. So we can say or, and now we're essentially going to do this whole thing again. So I'm just going to copy that, paste it right there, except for now everything's going to be right. So if the wall's to the right and the player's hitting key right and wall climb top right and wall kick right are all colliding. And then we should have 4 parentheses there. Sweet. And then we'll hit pass. Perfect. Okay, we got that right. So if all of this is true, then we say if not key jump. And now that's critical right there. States dot, and it's going to yell at us because there's not a wall slide state, but we'll add that in a second. So this is critical right here, because if we don't have that, the player just keeps like glitching between wall kicking and wall sliding. Usually you only want a wall slide if you're just like up against a wall and you usually hold that arrow key and you're preparing to jump off the wall. And this right here won't prevent, the way we have it programmed, it won't prevent wall jumping. So you can easily slide on a wall and then hit jump and wall jump off the wall. So it works wonderfully, but if we don't have that, the player just like freaks out and can't determine if it wants to wall slide or like wall jump. So that prevents that. So let's go back up to our state machine and add a node. And we'll call it wall slide. Perfect. And we'll attach a script called wall slide state. Save it into our state machine folder. Create. Perfect. There we go. And now this state is going to be quite simple. So this is going to extend player state. Now, don't peek. I'm going to paste in some code that we're going to go over ourselves. But just don't freak out because you saw that. It's just easier for me to do it like that. Yes, we know that function doesn't exist. Oh, look at that. That function exists. Wow. Perfect. And then as always, if we add a new state, we have to come in here and add it to our list of state nodes. So this is wall slide equals wall slide. And if you're wondering why like for our player, when we do our on readies, how we have to do like all these slashes, but when we look at our states, we don't. That's because the player script is attached up here. So we have to do slash player slash state machine slash locked, for like raycast slash wall jump slash wall kick left, because we're coming from this script. But because our state machine, the script is at this level, we can just say locked because these are all like childs of the state machine. So we don't have to go like state machine slash idle. It's just we're already in that folder to say. Alrighty, perfect. So in our animation, do this one real quick. Player dot animator. I spelled it right. Let's go. Equals, or we want to play the wall slide animation, and we want to flip the sprite depending on player dot wall direction equals vector 2 dot left. So if it's to the left, then we do want to flip it so that, because the player faces right normally, so we want to flip it to face the left. Alrighty, not going to do anything with that state. Okay, so now we're going to come up here, and first thing we're going to do is we're going to add a constant. So this constant is just local to this state because we literally don't care about it just for this state. And we're going to call it wall magnet speed, and you'll see what that does in a second. So we're going to say if player.wall direction equals vector 2 dot left. We're going to set the player velocity dot x to equal negative wall magnet speed, and then we say elif, and we're going to use an elif because we really want to make sure that we stay like we really want to make sure it's either left or right. Technically, we could just default and be like, oh, if it's not left, then it has to be right. Which we could make that assumption because we're in this state, and the only way we can get into this state is if we are up against a wall based on this function right here. So what this does is sometimes, because the raycasts detect 3 pixels out from the player, so they can detect all the way out to the point, sometimes, like the player would grab the wall and be like 2 or 3 pixels off the wall. So essentially what we're doing is we're just saying, hey, whichever we're in this state, just whichever direction the wall is, just basically set the player velocity so fast that it'll just, move the player right up snug against that wall. So there's no space between the player and the wall. Hence it's called wall magnet speed. We basically just magnetize the player to the wall, and you can't even see it because it happens so fast, but it just graphically, it just makes it look much better. Alrighty, and then now all we need to do is go into our player state. And if you see my mouse keep running off the screen, that's just because I have the code that I programmed over here, so I can see it in program. Alrighty, so we'll kick. Okay, so now we're gonna do const wall slide speed. And where did I put that? It's right there. And that's going to be equal to 40. Back to wall state, we'll say function handle wall slide movement. So we're going to say if player dot wall climb direction equals vector 2 dot 0. Okay, I'm getting ahead of myself real quick. I forgot that I implemented wall sliding after I implemented wall climbing. So we're actually just going to switch that to wall direction. It'll work the same. It's just for wall climbing, I made a separate variable just to make sure that there wasn't any confusion between the two and that they didn't interact with each other. So, but setting it to wall direction, they literally work the exact same. So we're just going to use wall direction for here. So I say if player dot wall direction equals 2 dot left and player dot key left, or, and then we're going to check the other side. So player dot wall direction equals vector 2 dot right and player dot key right. So if the wall is to the right and we're hitting right, or if the wall is to the left and we're hitting left, then we're up against the wall. And so we're going to say if, and then not player dot key jump, because that's going to interfere with this. Player dot velocity dot y equals player dot wall slide speed. And then outside of this, if we're not, hitting the keys to stay in the state, then we don't go into caps lock and we change state to states.full. Okay. Now if we go here and we say handle wall slide movement, there's those functions, and then there's a few more that we need to do. We need to say player.get wall direction, player.handle landing, because if we slide all the way to the bottom of the wall, we want to go onto the ground and not stay wall sliding. And then handle wall jump. And once again, that's why we've put all of these functions in the player state, because we're going to use them so often that it just makes sense to do that. Alrighty, this should be implemented and should work. So let's give it a go. Ah, yes, that should work, but we have no way of getting into that state. So in our false state, we're going to add player.handle wall slide without a capital L. And the reason we don't put it in jump is you want to be able to jump next to a wall without like suddenly sliding and falling. So now if we do that and we jump into the wall, perfect. And then see, player hits the bottom and we go into the land state, but we're sliding. Nice. Let's go try the other side. Perfect. And see, we can jump off it. So our wall jump works. I can slide, jump, slide, jump, slide, jump. And I can do that all day long. Perfect. Alrighty. Next up, we're going to add climbing. And so we're going to split this into two states. We're going to add, the first one is going to be wall grab. So this is like the idle. So you're just grabbing and holding on to the wall. And then we're going to split it into wall climb. Now, could you technically merge these? Yes, but you could also merge idle and run and jump and fall. But who knows when you're going to want some different functionality in idle that doesn't apply to run, or who knows. Well, in this case, we do want these to be split, and one of the reasons is just grabbing onto the wall will use your stamina slower than climbing will. So climbing will use your stamina faster than just holding onto the wall will. So we split it into two states because it makes it easier to do that. Alrighty, now it's time to add all the constants that we are going to need for climbing. So first, constant climb speed is going to equal 30. And then constant max climb stamina is going to equal 300. And then just as a note, this is going to be measured in, like ticks, not seconds, as it can decrease at various rates. And that's what I was talking about, how like holding uses less stamina than climbing. So then we say constant grab stamina cost, and we'll set that equal to 1. So, you basically have like 300 game loops, 300 frames of holding, and then climb stamina cost equals 2. And yeah, so you have like 150 frames of climb stamina cost. And those should be the only constants that we need for that. And then, like I said, I used wall climb direction, but I think we're actually going to optimize the code and just use this one variable because I don't think they should interfere. If they do end up interfering, then it'll be a great learning experience on YouTube and we can go from there, but we should be just fine. So next up, let's go to project settings, input map, add a new input, we'll call it climb, and I'm going to bind the Z key because we got C for jump, Z for climb, and then X will be our dash, which will be, I think the next video actually might be dashing, and you're gonna like it. We're gonna dash real well in this game, and it's gonna look cool. I've been messing with some special effects to really make it look pretty, and so it will. Alrighty, function handle wall grab. So we say if not key climb. Nope, I'm looking at the wrong function. If wall direction is not equal to vector2.0, and we say if key climb, which we haven't actually defined yet, and climb stamina is greater than 0, which we also actually technically haven't defined that, then we would change our state to states.wall grab, which we also technically haven't defined. Okay, so back up here, key climb equals false. Perfect. Put it right here. Variable climb stamina equals max climb stamina. And now we have to go down to our input function. So get input states, and we'll say key jump equals input.is action pressed climb. Alrighty, there we go. So that's all set. Now we just need to add the wall grab state. So wall grab state machine open, save it there. Perfect. So our wall climb state will extend player state. So this is wall grab. And then same thing, we're going to add the wall magnet speed to equal 50. And we're going to get rid of these. And then I'm going to paste in the enter state function. So wall grab magnet speed. So set the player velocity, so both vertical and horizontal, to 0, and then magnetize up against the wall. This is the same code we have in the wall slide. Next, we're going to have actually lazy boy programming. We put those functions in. And now we're going to say function update based on delta. We'll pass for now because we need to get to other functions. Alrighty. Function handle climb. So this is where we'll actually handle the climbing motion, and it's actually quite simple. We say if player dot key up or player dot key down, we states dot wall climb. It's easy. So because this is just the grabbing state, not the actual climbing state, we just see if we want to climb, and then we go to the climb state. And then we'll do handle animations. And the same thing. These are the same lines of code that wall slide has. So we'll play our wall grab, and then we'll flip the sprite. So then in our update, we need to pass in a few different functions. Player.handle wall release. And that we need to go code, but that is, it just sees if we let go of the climb button and puts us in the false state. And we want to handle climbing. So we transition to the climb state, which actually we're gonna comment that out real quick because there is no climb state. And then this is what we're gonna say: player.climb stamina minus equals player.grab stamina cost. So that'll update our stamina and decrease it. And then we want to be able to wall jump, so we handle wall jumping. And then last but not least, handle our animations. And then here we'll say handle wall release. And this function is actually quite simple. We say if not key climb change state states.fall. And then we'll say elif climb stamina is less than or equal to 0. So this will handle both like letting go and running out of stamina. Kind of a double whammy. And let's actually optimize this code. So if we're not pressing climbing or this one, so if either of those are true, change state to fall. Shorter function, more optimized code. We love code optimization. We'll see if I remember to optimize that before I upload it. Okay, so do we have the wall grab state? We don't. So on ready, there, wall grab equals wall grab. And then we'll add this one in so we don't forget later. Wall climb equals wall climb. Alrighty, so wall grabbing is there. So now we need to choose which states we want to be able to grab a wall and which states we can't grab a wall. So in our false state, we want to be able to grab onto a wall. So we'll say player.handle wall grab. And then in our jump state, we also want to be able in our jump state, we actually want to be able to handle player.handle wall grab. And we're also going to add in here player.get wall direction. Because remember, we were using wall direction to handle the wall grab, and actually we can optimize this. It's funny how like I come back to code and I'll be like, oh wait, we can optimize this here. Oh wait, we can optimize that there. So like now if we go to fall, so that'll call that there. Jump. No, we should be good. Alrighty, let's see if wall grabbing works. Nice. Errors. Yeah, okay, I know exactly. It's going to point us to. It's going to say that, but it's this one right here because wall climb doesn't exist. So let's just add the wall climb state real quick. And if you're wondering how I knew that, um, because you'll see in player state it was pointing us to this line, and you're like, oh my gosh, how did he know it was the wall climb state? I've run into this error so many times, especially when I was like building this state machine, that I just know whenever it says that, it means that we're trying to transition to a state that isn't on this states list. And we had wall climb, but there wasn't a script attached, and so it wasn't a state technically. So now it should work. Perfect. Okay. Ooh, hold up. We can't jump anymore. Something's going on. And we can't wall climb. Okay, we coded something wrong. Okay, handle, wall slide. That's good. Handle wall grab. So if direction is not equal to vector 2.0 and key climb and key stamina is greater than 0, change state, handle wall release. If not key climb, states that fall. Okay. Where is our state machine code? This is the world's greatest debug statement. Okay, so in the jump state, we're handling wall grab. Let's see if that fixes it. Nope. Okay, so that's not throwing an error. Handle gravity, handle horizontal movement, handle wall jump, handle wall grab. Okay, so that's the order I have. Let's see if that affects things. No, so if not player key jump. The key jump is being held. So one of these functions, that's not causing the issue. That's not causing the issue. That allowed us to jump, but obviously that makes sense because that's handling the transition and our variable jump. Is that supposed to be an elif? Yeah, we do have it as an elif. What if we get rid of that as an elif? Yeah, see, this is interesting because I did not run into this issue in my other project, which means we've got something coded wrong somewhere in this project. Because in my other one, it's working just fine. Oh, you know what? I don't know if that'll fix. If not key climb. I don't know if that'll fix that issue, but we will need this function in here. Handle wall grab. So get wall direction. We are going to need this function. So this is get wall climb. So this is going to be raycast wall kick left and raycast climb left. And this is going to be wall kick right, and this is going to be raycast wall climb right. And then wall climb direction is another variable we need. So variable wall climb direction. If any of you saw that error coming ahead beforehand, very smart of you. Okay, so then in here, Wall climb direction. Wall climb direction. Perfect. I know there was somewhere wall slide. Yeah, this one. We're going to make wall climb direction. Why? Because I want both the upper and lower ray casts to be contacting in order to wall slide. Okay. So like I said, I don't think that'll fix the jumping error we're running into, but yeah. Alrighty, I'm gonna have to pause this video because it might take me a hot minute to actually debug this, and as soon as I figure out what it is, I will unpause and get back to it. Alrighty, I'm back. I found it. If you notice this when during the video, then props to you. We didn't set key climb, we set key jump. So it's obviously going to be triggering a false for our jump, therefore preventing us from jumping. And whoop-de-doo, there we go. Hey, and we can climb too. We just faced the wrong direction. Sweet. Anyways, so real quick to run you through my debug process, just because I know some of you really appreciate seeing that. So this is what I was following. We go to idle, we go to jump to fall. So we're immediately going to fall. However, I looked at my jump state. My jump state is identical to my other state. So I'm like, okay, there's nothing wrong with this code because it's identical to the other code in my other project that works. So I'm like, something else is going on. So I said, maybe something weird is going on with the rate casts, which honestly doesn't really make sense because we don't check, or we do kind of check the rate casts. So I turned on the rate casts. Nothing was going weird with them. They were working just fine. So I said, okay, let's go check my inputs. And I said, is the input the same? Yes, climb is Z, jump is C. They're set to separate inputs. I was like, okay. So, and why did I go to, first off, why did I go to inputs? Because of this line. If the jump input changes, then the player stops jumping, the variable jump. So something was going on with the inputs because everything else was fine. So I went back to my player, checked my inputs, and sure enough, this said key jump and not key climb. So that's how we found the error. Alrighty, let's go to wall grab, handle animations, wall climb direction. I think this can just be wall direction to get that animation just right. Yeah, there we go. Perfect. Oh, and see, our stamina works. But now we have no stamina. Ooh, no stamina. But that's an easy fix. We just go to our handle landing right here, and we just say climb stamina equals max climb stamina. So now whenever we land, our stamina is reset. So if I hold here, our player will fall in a second. And then, yep, see, so now our stamina is back, so we can jump again. Oh, but it didn't magnetize that time. Interesting. I wonder why. Project. Alrighty, we'll come back to that in a second. Let's get the rest of the climbing implemented, and then we can worry about that. So let's go to our wall climb state. I'm going to add in the first couple of functions. So enter state, wall climb, exit, draw. Don't really use those, but they're there in case we need them. You might use them in your project. We're going to have our update based on delta. We'll pass for now. Handle, climb, movement. All right, so here we're actually going to climb. So we're going to say if player.key climb. So make sure we're actually still wanting to climb. Then we say if player.wall climb direction is not equal to vector2 dot 0. So there is a wall, which, like I said, these checks are technically already like there. So these are kind of redundant, but better safe than sorry. So now we say if player dot key up and player dot raycast, and I'm going to go copy the name because I don't remember it. It's too long. So limit, climb limit, bottom and top. Okay, that's what it is. Raycast, wall, climb, limit, wall, climb, limit, top left is colliding. And this needs to be, or we're going to copy this whole line right here, paste it, and this is going to be top right. And we set player dot velocity dot y to equals negative player dot climb speed. So if we're going up and either the left or the right is colliding, so we're not necessarily caring which way we're facing, we're just seeing that the limit raycast is actually colliding. Then we set the player to that climb speed. So now we're going to say elif, and we're essentially just going to copy this whole thing, except for now we're going to say key down, and then this is going to be bottom left or bottom right, and then we're going to set this to positive because we're going down, so positive. And then we're going to say else, if none of that's happening, change state to states.wall grab. So we're not hitting up or down, so go back to wall grabbing. And then outside of this player, if we're not grabbing, then change states to states.fall. Wow, bad coding. Change states.fall. And then handle our animations. So if player dot velocity dot y is greater than 0, we're going to say player dot animator dot speed scale equals -1. So this is like the scale at which like the speed's playing. So like 2 would be like 2 times speed, but -1 is reverse speed. Else player dot animator dot speed scale equals 1. And then we'll play the wall climb animation. And player dot sprite dot flip h is going to depend on whether or not the wall climb direction equals vector 2 dot left. Error at 32.1. Yes, that would be an error because we are accidentally indented by 1 tab. And there we have it. Okay. So now in our update, we're going to call a few different things. We need to update our wall vectors, so get can wall climb. And then we need to decrease the player by a factor of climb stamina cost because we're climbing. We need to handle our wall handle climb movement. Player dot handle wall release. Player dot handle wall jump, and then handle animations. Okay, so let's see if this works, and then we'll figure out that magnetizing thing. Yep, nothing's happening because in our wall grab state, we never transitioned to the climb state. Yes, an air. I love airs. Key climb. Seriously, you guys should start keeping tabs of how many times I double capitalize and it runs into an issue. Okay, there's another one. I guarantee you it's a double capitalization. Yep. Wall climb. Maybe I need a new keyboard. We'll blame it on that. Okay, so now we're climbing up, and then we should run out of stamina. Perfect. Ooh, gross. All kinds of gross. Okay. Okay, so going down now throws an air. Animator. Animator. And a Mator. Okay. So I can go up. We can go down. Interesting. I don't know what's going on right there that suddenly those ray casts stop working. As soon as we grab, okay, see, like that time they work, we can go up, but then they stop. That is so weird. I'm very confused. Because like I said, the other project is working so well. Because we can go up, and suddenly those ray casts stop colliding. That's as soon as I let go of the input. Okay. That's so weird. As soon as I let go of the input in the climb state. Okay, let's make sure we have this code right then. So if player dot key up and player dot raycast wall climb limit top left. Just checking some raycasting. Okay, no, these should just be wall climb top left, wall climb top right. So this should just be wall climb top left, wall climb top right, and this should be wall climb bottom left, which doesn't exist because the bottom ones for our player are wall kick. No, that should be the limit. Sorry. Limit top left, limit top right. Limit top left, limit top right. Okay, so it's when we go to the wall grab state. That's when we're having the issue because if we find this right here, see how we go to wall grab? That's where everything goes skiwampus. So the wall grab state. Let's go back to wall grab state. So wall magnet speed. Set that to 0. If player.wall climb direction equals vector 2 left, velocity.x equals negative wall magnet speed. But if wall climb direction is right, positive, okay. And we handle wall release, we handle climb, we handle wall jump, and we handle animations. Key up or down, handle animations, wall grab equals wall climb direction. I am so confused. Okay, I'm gonna go debug hard mode right now, and I'll be back and talk about where this error is and what caused it as soon as I find it. Alrighty, I'm back. I'm gonna be honest with y'all. I got it working. I don't completely understand why it was acting weird. I'm by no means an expert in Godot, but what I ended up doing is I literally compared everything from the template project to this. These raycasts were all right on the edge of this hitbox, but in my other project, they were all nudged in one. So I nudged them all in one, and then I made a few changes. We used to call, or actually, in all honesty, let me see if adding this one change back will now work. Because I'm just curious, because I don't think it was this that was the issue. So handle wall grab, we need to get can't wall climb. Yep, okay, see, so now that's working as expected. We jump over here. See, we're also now magnetizing. See how we're always snapping? Ooh, fun. See how we're always snapping? Interesting. Okay, so that's not supposed to be happening. Figure out what's going on there. But yeah, see, okay, so now that's working. We're climbing up, we're climbing down. So literally, the one thing I changed, and in the previous video, we've had issues with raycasts. Maybe there's some internal functionality that I just don't understand, but internalizing these raycasts by 1 pixel, suddenly it all works. So there we have it. I don't know why, but it's working. In terms of what we just saw where the player could jump with only the feet contacting, that should not happen because this should prevent that. So we get the wall directions. Yeah, see, because this is checking both. Okay, and that's why, because this is wall direction. This needs to be wall climb direction. Okay, so that did come back to bite us. I said, oh yeah, it probably won't, but it did. It did come back to bite us because by checking just the bottom one, that's why we could climb. See, like if I go like that, see, it won't climb until we fall far enough to grab. Perfect. There we go. Well, this one was a bit of a roller coaster, but I hope that one, you understand the logic. The logic is all there. The logic all makes sense. It's all working just fine now. In addition to that, I hope that you saw some valuable insight into how I debug, because debugging is very important. And not everybody will be around to show you and tell you how to debug, but I do my best to try and let you all in and see, kind of how I approach issues like this to make sure that I can help you learn. Because that's the whole point of the series, is to help you learn so that you can become your own independent game developers. So if you like this video, please like, please subscribe, please leave a comment. We're trying to hit 500 subscribers by the end of 2024. So with your help, we can do that. Thank you, and I will see you in the next one.